Okay, good morning. I am going to do some review problems with you from chapter 12. I'm sorry, from chapter 11 in order to prepare us for chapter 12 because some of the students in class have not had, they have not gotten to this topic yet in algebra, and they have it at the same time as they have trig. So we are going to review a few problems from chapter 11, which is radicals and exponents. So what I'm going to do is do the problems with you. These are the examples right out of your textbook, starting with example 1, where we have exponents. A to the third minus, or times, sorry about that, let me erase that. A to the third times a to the negative 5. When you have negative or positive exponents and you're multiplying, remember what you learned in Algebra 1. You always add your exponents. So this would give us a to the 3 plus negative 5, which is a to the negative 2. What you might not remember, or you might not have learned, is that when you have a negative exponent, you then have to move it to the denominator in order to make it a positive. So we have to leave something in the numerator, so we put a 1. In the denominator, we have a to the second. Because to simplify expressions in algebra, you can't leave negative exponents. So we've now changed that from a negative exponent to a positive exponent by moving it to the denominator. Let's try a second problem. And it would really help if you had a piece of paper and we're trying these on your own. I can give you a second to try them before I put the answers. Again, this is chapter 11 in your text. Next problem I'm going to put up here is a squared, b to the third, c to the 0 divided by ab to the 7th. I want you to take a second and try to do that problem before I show you what the answer would be. Do we get it? Okay, here's what it should be. 1 second, I'm setting up my timer to make sure I don't go too long on my video. Okay. What this is going to do is there's a couple different things to notice here. You have a c to the 0. Anything to the 0 power is what? That's right. Anything to the 0 power equals 1, the number 1. So now we're going to get rid of that. So we have a squared b to the third times 1, which is just going to be a squared b to the third, over a to the first b to the 7th. To do exponents when you're dividing, you're supposed to subtract them. But you have to subtract where the highest exponent is. In other words, the a squared is on top, the a to the first is on the bottom, so we start on the top and take a to the 2 minus 1 times the 1. But look at the b's. The b to the third is on top, the b to the 7th in the denominator. That's higher, so we have to subtract down here, 7 minus 3. So we would get a to the first times 1 over b to the 4th, which is just a over b to the 4th. And you know that you're done because you have no negative exponents. So that's how you handle that. Another thing to think about, if you didn't understand the subtraction, if there are 7 b's under here, 3, 4, 5, 6, 7, and 3 b's up here, if you start crossing them out, where would you be left with b's? In the bottom. How many? 1, 2, 3, 4. That's another way to get this if you don't understand the subtraction. Okay, problem 3 for you to try. Again, this is all review, and hopefully it should be coming back to you. X to the negative 2, y to the third. We have to be able to understand exponents and radicals before I can start you on complex numbers, which is our chapter 12, which is what we should be doing. When you have a power to a power in a quantity cubed, you have to cube each one of the terms. So a power to a power, you always multiply your exponents. So we would have x to the negative 2 times 3, y to the, remember there's a first there if there's nothing listed, 1 times 3. So we get x to the negative 6, y to the third, but we're not allowed to leave negative exponents as a simplified answer, so you have to move that to the denominator. Your y cubed is positive, so leave it in the numerator. You only have to move the x to the negative 6 to the bottom to make it x to the positive 6. Everything is in positive exponent form, so we're good. That is simplified. Problem 4. Try this one. X squared y squared over times 2 over x to the negative 2. I'm going to give you a second to look at that, although probably it'd be better if you just followed me through on this one. These can be taught or can be done different ways. If you have a different way to do them that is mathematically correct, that is fine. You don't have to follow my way. I'm only showing you what I do so that you understand when we get to chapter 12 how I'm getting my answers. So let's take the first quantity, x squared y to the first, and let's raise it to the second power. Power to a power means we multiply. So we would have x to the 2 times 2, y to the 1 times 2, times, now look at this negative exponent. The negative exponent tells you you're supposed to put it in the denominator, but here's another way you can do that. When you have a negative exponent, if you have a fraction inside, you can flip the fraction and make it to the second power. Let me show you what I mean. You can flip the inside, put x over 2, and then just make this to the second power. We've eliminated the negative by flipping what's inside. That is one way to do it. There are other ways to do it, but I like this way the best. So now we have x to the fourth, y to the second, times, raise your power to a power, x squared over 2 squared. Don't forget to square your 2. Equals x to the fourth, y to the second, x squared over 4. Now we have 2 x's here that we can combine. Remember, you add exponents when you're side by side. So we get x to the 4 plus 2, y to the second over 4, and that equals x to the sixth, y to the second over 4. And that's how you simplify that problem. Hopefully you're doing okay with these. Let's move on here to the second page. Okay, this again is chapter 11. Review. Okay, if you see a problem like this, these are just different types of problems that you'll see. Negative 5, x to the 0. Keep in mind that your x to the 0, anything to the 0 power equals what? That's right, it equals 1. So this is really negative 5 times 1, which is just negative 5. That one will get you. Be careful with that x to the 0. They throw that a to the 0, b to the 0, x to the 0 in so many of their problems because they know they're going to get you on it. But don't let them get you. Just make it a 1. Okay, let's try this problem. Let's understand exponents and roots. 8 to the 2/3. Maybe you've never seen this before or what it means. What it means is this. This 3 refers to the index. This 2 refers to the power. And this is your base. The 8 is your base. What does that mean? We could rewrite that like this. 8 is here at your base. It's also called your radicand because it's under the radical sign. The index is the bottom number. That goes out here. And then the power is the 2. So we can write that like this, to the second power, or there's 2 ways you can write it. And you do whichever one works out easier or best, depending on the problem. We could write it like this. 8, the index is 3, and we put the squared in here. We do whichever one works out easier. So let me show you how these work if you're evaluating this. This first one, you take the cube root of 8. Remember how to do cube roots. What are cube roots? Well, cube roots. So let's look at those. 1 would equal 1 times 1 times 1, which is 1. 1 is a cube root. If we take 2, we would get 2 times 2 times 2, which is 8. 8 is a cube root. 3. 3 times 3 times 3 equals 27, and so on. You just keep going up in the number system, and these are your cube roots over here. So since we have a cube root of 8, what times itself 3 times gives you 8? That would be the number 2. This comes down as 2, and we have it to the second power, which is 4. The other way to do that is keep the cube on the outside, take your 8 and square it. 8 times 8 is 64. How can we rewrite our 64? Cube root of cube root of 64. What could we break 64 into? How about, my pen isn't working, there we go, cube root of 64 could break down into 8 times 8. Why would we do that? Because we could take the cube root of 8, which comes out as 2, and we can take the cube root of this 8, which comes out as 2, and we get an answer of 4. So either way, you get the same answer of 4. Just understand what this represents, which is your index out here. Remember, if it's a 2, that's square root. If you don't see one, it's usually it always is square root. It's understood to be. So let's try another problem. So you take this one and you see if you can figure this out. We have 64 to the 5 halves. We got to figure that out. So I'll give you a minute to rewrite that. So we're going to do our square root sign. The 64 goes in here. The square is our index. It goes here. And we're going to raise it to the 5th power. What is the square root of 64? We know that that is 8. Therefore, 8 to the 5th power, you have to use your calculator for this one, equals 32,768. Okay? Let's try an easier one. 16 to the 3/4. So you try to do it. Set up your 16 radicand, index of 4, and it's to the 3rd power. Again, I could write it like this, or I could write it the other way up here. It just depends on which way works easiest. Now the 4th root of 16. 4th roots, oh my goodness, 4th roots. We did cube roots, let's do 4th roots. 1 would be 1 times 1 times 1, 4 times equals 1. What would 2 be? 2 times 2 times 2 times 2 equals 2 times 4 times 2 is 8 times 2 is 16. Good. 16 is a 4th root. It equals 2. We can stop right there. So the 4th root of 16 is equal to 2, and we have it to the 3rd power, which is 8. Okay, how we doing? Hopefully we're hanging in there. Now, I'm going to keep going, but I'm actually going to have to do a second video because my videos are limited to 15 minutes. So I've got another minute. I think I can get another problem in here. Let's try.